The researcher in the previous example decides that the training may actually make short-term memory worse, so he decides to use a two-tailed test at the 5% level. Determine the critical region for a two-tailed test. Now, if we recall, the null hypothesis was that p was 0.4, that a student remembers 40%. In the previous example, though, we were just testing to see if the training made things better. So the alternative was p was greater than 0.4, but here there's a suspicion that it may make it worse. So it could make it better, could make it worse, and therefore the alternative is just that p is not 0.4. So we need a test at both ends, and we're going to do it at the 5% level. Now, from the previous example, we found that 9790 gave us 2.1%. Now, with a 5% two-tailed test, we split that and make it 2.5% at either end. So this is still fine, and remember this was 5%, so we can still have a critical region here. Now at the other end, so this is 0.36%, this is 1.6%, and this one is 5.1%. So that's too much. Remember, we can go up to 2.5%, so it's going to be here. So our critical region is 3 or less, or 12 or more.